Hi, Jim. Welcome to Concentrating on Chromatography.
Thank you. I'm very happy to be here, and it's the first time I've ever done a podcast. I'm super excited.
That's super exciting. Yeah, and I would say that a lot of the researchers I speak with, it's their first time as well. So nothing to be nervous about there. But as an introduction, could you briefly describe your role at
Sure.
Agilent?
I am the Associate Vice President of Marketing for the Gas Phase Division. We have responsibility for GC and GCMS, product marketing, application scientists, content creation for Agilent worldwide. This is a special month because it marks 34 years that I've been with HP Agilent. I spent 22 years in R&D. My background is software, and I joined marketing in 2013 and did product management for a little while. So, yeah, it's been a really great experience and ride through the industry.
From your vantage point at Agilent, how has the typical chromatography user changed over the past 5 to 10 years?
Sure. So, we've been watching the demographic of our users changing, let's say, I think over the last 10 to 15 years. What they expect from technology today is completely different than a decade or two or three ago. They're using these systems to just get a job done. They don't really necessarily have time or even the desire today to deeply understand the inner workings of chromatography or the system they have. They're just using them as a tool. I have adult children now, and my oldest is working in a medical laboratory at a local hospital. She was in middle school when she got her smartphone. It was attached to her hand, grew up in the age of social media, didn't really understand necessarily the cloud or where the data was. It just gave an answer. It was just a tool. And I think that's kind of, can relate to a lot of people today. People are busy. They've got smartphones, mobile devices, Internet of Things in their homes, and they expect a lot more from technology today. And these are the users that are in the laboratory using equipment. They're consumers and they think that the lab equipment should work like everything else they experience.
There's always a pressure in the lab space or other organizations to do more with less. How is that reality changing the profile of who is at the bench and the support they need from their
Yeah, I
instrumentation?
think we're seeing labs increasingly trying to operate with less staff in laboratories where you go into a lab and there's one or two people for a whole room full of instruments. They're tasked with getting an analytical result. They often have to do that quickly. They might be a contract lab that's just using samples as a revenue stream, or they might be a service lab that needs to get an answer fast. And they're doing it with less staff because they want instrumentation that's ready to run and easy to maintain and not have a lot of extra overhead. So the systems have to be a lot more capable and ready to go, a lot more self aware. You know, I can relate a story. We were visiting one of my customer visits in Europe. We were visiting a facility that made dyes and inks for newspaper print box, cereal boxes, other stuff like that. And a tanker truck will pull up to their facility on the street. They have exactly 1 hour to either offload that tanker or send it away. So they go out, take a sample, it gets brought into the lab, and they have to get an answer within 60 minutes, or they start receiving heavy fines from the local city. So, they need to get answers quickly. We've visited users. There's another, this is kind of a fun story. There's fuel that is regular gas, like we buy at the gas pump, and then there's agricultural fuel that's dyed and red diesel or whatever they call it. And that red diesel is not taxed because it's for the ag business. Well, there are, let's say, people who will take the red dye gas, filter it to remove the dye, and then sell it at gas stations with the tax. And they're not doing that in a, let's say, in the proper fashion. So there's law enforcement agencies that have analytical equipment in mobile vans, and they want to roll up on a station, take a sample, get a quick result before they make a decision to shut something like that down. So there's lots of instances where you need an answer quickly. You could look at many in the chemical and energy industry at refineries and chemical plants. There's something going on in the refinery, a reaction, and an urgent sample comes to the laboratory, and you need to be able to hand that off to a user, load it on a system that's ready to give an answer, and then go make a decision in the plant before they lose product or some reaction goes bad. So those are just a couple examples, but they're doing this with less staff than they ever had before.
Totally. It's funny you mention visiting customers in Europe because one of my few visits that I've made in Europe was actually to an Agilent lab outside of Manchester, UK, where our evaporators are
Oh,
used
excellent.
to evaluate samples and prepare them for
That's really
analysis.
cool.
And we certainly see that for our instrumentation is more heavy duty, affordable, and geared more to an academic audience, honestly. So there's certainly for some of the larger solvent evaporators could be much more expensive, but the economics make sense for that type of lab in that they might be saving so many thousands of hours of manpower in terms of that automated sample preparation. So it really depends on the goals of the specific operation,
Yeah,
let's
no,
say.
that's really very interesting. I'm sure that most of your listeners and viewers know BC and GCMS are used in broad-based end markets, chemical and advanced materials, and energy is part of that. Food, environmental, forensics, pharma, just about every end market that we serve have places for GC and GCMS. So we get to see so many exciting so many exciting uses of instrumentation. I'll mention one more and then we can move ahead, but this is my favorite one. I'm a big Formula One fan. I like watching F1. And there are a number of teams that have GCs in the pit lanes in the paddock to do fuel testing. The governing
Wow.
body is testing the fuel, and the teams are testing the fuel, and they're making sure it's compliant with the regulations. Still haven't managed to get a customer visit on site, but that's my dream one day to go to a F1 race on behalf of Agilent to go visit the use of our equipment there.
Awesome. Well, I think it worked out this year that MJ BizCon annual event in Vegas was pretty close to the time of the
Mm-hmm.
F1 race. And I know they have a small part of that show devoted to lab
Yeah,
equipment for the cannabis space.
excellent.
That was probably the question I was most excited to ask Lee Pollitt in our last
Yeah,
episode was what are just some of the crazy applications of GCMS because he's trained over 14,000 people. So I knew he would
yeah,
have some cool answers. And yeah, the F1, like you mentioned, that's something I never
yeah.
would have
No,
guessed.
our teams have been all over the world. Our product managers, our service teams, we have a global presence. And we've had team members who've had the chance to go to laboratories in all countries. And you find there's plants that make paper products, and there's a product testing lab. It's a corner of the factory floor with like almost like a temporary wall. And in one site that we've seen, there was a GC headspace there, one system, but then they had a number of other types of material testing things for the products that they were making. These types of usages are you can find all over the globe and not necessarily in places you expect, but there's many processes that require an analytical measurement, and they managed to get the proper instrumentation, be it LC or GC or spectroscopy products in place to do that. And sometimes it's surprising to learn about a new use.
I always say how cool it is in my position where if I go into a lab and I know they're doing EPA applications, I know exactly what they're doing down to the steps in the instrumentation because I can look all of that up. Where I mentioned academic lab, I go in there and it could be anything, any sort of research. So it's always exciting to walk in and learn about a cool
Yeah.
application. Speaking of collecting user feedback, I'd love to get some insight from you in terms of how Agilent collects and prioritizes some of that user feedback and how it can be used to refresh the platform and make the experience better for the users.
Yeah. So, collecting user feedback has kind of been, I'd say, in our DNA since we were Hewlett Packard and became Agilent. And we get user feedback from a variety of sources. There's the kind of traditional ways of we go out and interview users in their facilities, go visit them in their laboratories, and have questionnaires, open-ended questions. You never want to guide the witness when you're doing the customer research. You want to get them to have some imagination and tell you, really tease out really what their pain point or what their problems are. So there's a lot of that kind of traditional customer visit, open-ended interview questions, a laboratory tour, kind of seeing it in action. We also get feedback on use of our system from our front lines, our sales, our service, other parts of our business. Our service teams see customers every single day. So we have vectors of getting input from our internal teams in Agilent. We also have a robust amount of data in our quality systems. So customer surveys, if there are any instrument issues that get reported, we can mine that data and we look for opportunities of, okay, what's a common customer reported problem and what might be the root cause, and how do we build that into a next generation system? These are all the different vectors that we could get user feedback on. But I want to share a little more detail on the product lifecycle, product development, where we get feedback. I'll break it in a few just very quick decades. In the 90s, we were doing paper prototyping. I mean, literal paper prototyping. We would make flip charts and little notebooks with screen concepts for software and then go visit customers. I remember we were going around with like a dozen or so of these notebooks. We had human factors people we were working with. You'd sit in front of a customer and pretend that that was the interface they were using, and there were highlighters and sticky notes, and they could modify the interface to kind of suit their need, and they would bring that back to come up with an implementation. A decade later, tools got a little bit better. You could do the same thing with PowerPoint. You had wireframes in the early 2000s. The software capabilities were getting better to do that kind of prototyping. We would do similar things with hardware prototypes in the life cycle, bring customers in to see concepts that we're developing, get their feedback to see if it would address their needs. Tools have gotten a lot better today. And now you can do very rapid prototyping, especially in software. You do rapid prototyping in software, get screens that kind of almost sort of look like they work, even if they're not completely implemented in the back end. Then you can put users in front of cameras that are tracking eye movements and head movements and mouse clicks, and you can see where they're looking on the screen and if they're rage clicking something or getting the workflows. The tools have been very advanced, and we employ all of these kinds of things in the product development process. Most recently, we have been engaging, and this is the overall initiative. If you've heard Porig and the executive team talk about Agilent and the customer first mindset, we're engaging with our users at the early stages of product concept and development under confidential agreement, right? You can't do all of that without some protection. But you do this, and you bring them in very early, and the results are amazing, because what you learn when you get them earlier and earlier in the process and kind of create that solution together, what you can bring to market really hits the things that worry. So like that they're trying to solve. So, be that footprint, easier to maintain. Did I get the right layout of the screens? Can I access the stuff in the right way? You get a lot of great feedback from our users when you involve them early in the process.
And in some ways, software is such a exciting place to be doing that R&D and testing work, because it can be so rapid, let's say, in terms of that.
Yeah.
Are you willing to talk about any of the common pain points and how that feeds into some of the design decisions that improve the traditional LC or GC systems?
I can highlight a few of those that you can see in the current systems today. One thing, when this goes back probably, let's say, the last 10, 15 years, because we did a big customer needs assessment around 2010 on a massive scale. And what we heard was they wanted systems that were easy to use, easy to set up, easy to maintain. I mean, the stuff that you'd expect that you hear, but in a concrete way. It's like, well, what do you mean easy to maintain? Well, I want inlet maintenance to be easy because my operators don't do it that often, and I don't have the experienced lab tech there all the time to do it, for example. So we took all this feedback, and in the intelligent systems that we've built in our instrumentation, we have tools that allow that. We talked about that one user responsible for a lab full of instruments. Well, now they can go up to the touch screen and on the instrument and say, okay, prepare for maintenance. They click a button. The system does everything it needs to get ready to perform that maintenance. And then on the screen, it'll show them step by step what they need to do. So they don't even really have to remember how to do it. They just follow what's on the screen. They can say they're done for maintenance, and then it will run an automatic system health check. It'll run a leak test. It'll make sure the system is suitable to run. And that takes the burden off of their worry and time of, did I do it? Did I do it right? Do I know how to do it? That's all built into the instrumentation. So, making it easy to set up, maintain. Can I connect and get my data anywhere? And I think maybe a little bit we'll talk about kind of connectivity. But today, with our systems in laboratories, if your enterprise is set up like in Agilent, we have a VPN and outside access. I can connect to the VPN with my phone, and if I know the address of my systems in the lab, I can access that GC or that else. I can get to the instrumentation remotely and get that data from anywhere I want. So I don't have to run into the office over the weekend if I've got samples up. I can see what the status is and how they're doing. So easy to set up, easy to maintain, easy to access. Some things that I think if we talk about some of the challenges that they have and where there's pain, customers spend a lot of time in data review and data analysis. And with some of the latest advances in software, in the mass spec realm, we have our AI peak integration for GCMS. We have the phthalates. We have, other offerings. But you're starting to see more advanced computational capability that's bringing real tools to the market that save significant time for our users. So those are a few examples. The other pain point that we hear from laboratories, the software landscape is complex. They have instrument vendor provided software. They have their own LIMS. Sometimes they have homegrown software. One of the areas I think we all benefit from is when there's standardization of formats or communication protocols. So, things like that can help go a long way in helping alleviate some of the pain in the lab for our users.
To connect this to the earlier topic of the current chromatography user and how that's changed over the years, I suppose the bar is continually set higher with so much technology in people's hands and how user friendly a product from, let's say, Apple is, that people say, hey, I want that same level of usability with an Agilent product. And it's something that I think we all face as lab equipment manufacturers.
Yeah, I definitely would agree with that. We've tried to hit the high points of things like the maintenance, the diagnostic capability of trying to make that really simple wizard-like screens. They step you through the process. We even have chromatographic processing capability in the instrument. Upon setup, they can do what's called detector evaluation, show that the detector is performing in a suitable way, it's suitable for running. There's blank evaluation. The instrument itself can do a blank run analysis and determine that a blank is really a blank. I love this one. We have a feature called peak evaluation. The instrument itself can do a integration and chromatographic analysis of the sample in the instrument at the earliest possible time that it could say that something is going off chromatographically in the result. And this is all set up by the user. So they can say, hey, I'm in a routine lab. I only care about these 5 peaks. If these 3 peaks, retention time shifts or the width at half height or whatever, some peak attribute, if it gets out of some window, I want it to stop the system. I want it to just flag it and continue. They can decide what action it takes. And that all happens in the instrument. Of course, that all flows upstream then to the data system and et cetera, that can be picked up by things like smart alerts. But at the point that there's a problem with the analytical result, that's the first time it could be caught. We can do that with peak evaluation inside the GC. And that can benefit the user in real practical use. I gave you that example of a refinery or chemical plant. They've got huge material and revenue at stake if something goes wrong in the process. If they can catch something early in an analytical result and get that back to the plant, that can make a big difference to them. We talked about the demographic of the user. They just want it as a tool. Go back to my daughter running the system in the lab, just hitting the buttons, running the sample. They just want the system to work. This can ensure that that can be deployed and implemented in a way that really takes that burden off of the users.
And from a user's perspective, is what you just mentioned a good example of what you would consider to be an intelligent instrument system, picking up on
Yeah,
some of
yeah. So
those challenges?
absolutely. So, an intelligent system, what do we mean when you ask that question? What is an intelligent system? It's exciting as a technology person. Technology is exciting. The smartphones, the tablets, building computers, we all get hung up on specs and stuff. But that's not sufficient to define an intelligent system. An intelligent system, in my view or our view, it's a feature that takes a workload or mental effort off of a user, and it can deliver the same or better result with very high confidence. So I'll give you a car example because I like these. I'm a Honda person. I'm on my third Honda Odyssey. And the new one has adaptive cruise control. It's got adaptive cruise control and lane assist. And I've never had that in a car before. That's game changing on road trips. And I got to experience that over the summer. You set the gap you want to follow, you set the speed where you want. That takes so much effort off of driving on the highway. That's an intelligent feature in that system. So if you go back and look at we've been building intelligence features for a long time in the gas phase platforms and other platforms from Agilent. So we have a feature called retention time locking. It's been built in for probably more than 2 decades or so. It's a functionality in the associated wizard when the user's doing column clipping or maintenance and they have to recalibrate a method for retention time shift. This retention time locking and the associated wizard makes that an automatic process. They just set it up. It does a few runs. It automatically updates the method. That's an intelligent feature. In mass spec, we have something called the MRM optimizer. If you're ever doing setups of transitions in mass spec, that's very tedious and time consuming by the analyst. Well, we have a set of capability called MRM optimizer that aids the user in automatic setup and saves significant time. I think we talked a bit about the instrument intelligence, the built-in maintenance, diagnostics, EMF tracking of consumables and stuff. We've actually had that for a few generations of instruments, but now we've even up-leveled the level of smart of those because that can all be analyzed together with what's going on in the instrument. We have a lot more power in our current generation of instrumentation than we had before. Like I said, it can do chromatographic analysis in addition to all of that. There's a wealth of information that can be served up from the instrumentation. So you can get all the help and documentation, step-by-step guides, access to all of the content that you might be interested in. And that can be displayed in a browser interface. You just put in the address of the instrument, and that shows up in a browser interface that you can access. It's a very rich experience, and that all comes out of the instrumentation. Intelligence is not a feature list of this piece and this piece. It's what does that mean for you to save time in the lab, and how do you take advantage of that set of stuff so that you can do more high value activity in the laboratory than worrying about maintaining your instruments.
Most of the listeners to this podcast are undergraduate chemists who are just starting their careers, and not to pick on them, but I think it's fair to say in anything that less experienced users might be prone to making more mistakes. How can the system intelligence really prevent some of those mistakes before they occur?
Well, once the system is set up and you have some of these features activated, the system between the instrument system and the software can flag an error or show a result so that a less experienced user can, if I had a picture I could show you, be more like the flag coming up on your phone with a little indicator saying, hey, there's an alert here that you should pay attention to. And I can tell you there's people that see alerts on their phones. They're like, well, what's going on there? So there's a lot more of that kind of automatic capability. Another thing that we have with this tracking of EMFs, early maintenance feedback consumables, how many injections have been on a liner or a septum or how many times the column has been run. There can be those things set up that allow somebody that's less experienced, it could do a check before running to say, okay, I've got enough injection time left, or there's enough headroom left in the consumables I'm tracking so that I don't run in, I'm not halfway through a sequence and then go, oh, time to change a liner. So there's a lot more aids like that for the less experienced user. So I don't want to discourage them from learning. I think everybody's got some natural curiosity, but there's a lot of stuff that is easier to use today than it was ever in previous generations. And then there's the wealth of information. If somebody's curious, they can go very, very deep down at looking into the documentation and resources that are available online. I should maybe mention here, we have a vibrant community on Agilent.com, and there's quite a lot of information about our product offerings built into the Agilent community. These new users out there to chromatography, if they don't know about it, it might be a really good place for them to go visit and see what they can get from the Agilent community.
Speaking of learning, and this was a main topic of discussion with Axion Labs during my last episode, but sometimes there's a tendency for these analyzers to be seen as magic black boxes, even though some of the basic concepts are fairly easy to understand. So there does seem to be this push and pull between what do people need to know? What should they learn over time? How can users feel in control while also taking advantage of the intelligence? And what's the right balance there?
Yeah, so words like automatic can be intimidating with new instrumentation. You know, at the end of the day in the lab, there's a person or analyst that's still responsible for the data. So you have to be in a position to build trust with the analyst that yes, these automatic tools are doing the job, they're doing it exceptionally well. But we have built flexibility into the intelligence systems that allow these users to explore at their own pace. So, you know, I'm trying to think of the right analogy for your users. So, you know, there's okay. So in photography, there's a lot of things that can be done for modifying your photos and videos, and there's a lot of like wizards and things that make adjustments. But if you're like, hey, I'm not sure that made quite the right adjustment, you can always go into adjusting exposure and looking at the different channels. You can go as far down that as you want. So I'd say we've kind of tried to strike a balance of there's a compelling amount of there to help users with the routine job they do day in and day out, or to help them with routine tasks to take a burden off or save time. But we've also have the ability in the interface for somebody that wants to explore, or they want to see kind of behind the curtains, so that it's not really a black box. It's more like a kind of automatic, but you can kind of go behind the scenes, and you can do that and hopefully learn that, yeah, this is working as it should, and you're not intimidated by the fact that the automatic stuff is working and turned on. There's tremendous benefit there that we are seeing with these features in the market, and I think it'll certainly take time for there's different we talk about the demographics of the new users. You didn't talk about the demographics of the, you know, people that have been around for you know, multiple decades of iteration of instruments. I think they're starting to be convinced because it's really good.
Yeah, and to connect that back to the feedback comment we started with at the beginning, I suppose, with some of those users who could be potentially set in their ways, there's a challenge of
There is.
adoption, and that's why you want to collect as much
Yep.
feedback as possible. And it's probably a good thing that I can't remember the name of the labs, but I've certainly visited some labs where they had an old laptop connected because whatever soft they were running needed Windows
Yeah.
98 or
Yeah.
something to be able to
Oh,
produce the right
they're
data
still
output.
out there. They're still out there. But I mean, that's the balance you have to strike. People get instrumentation, they use it for a job, they want to use it for a reasonable lifetime. I think we're in a very exciting period. I've been around to see multiple generations of instrumentation, but this current crop of instruments have more power, more memory, more connectivity, more capability than all the previous generations ever had. And I think that's kind of a parallel to the software universe. Like I told you, my background software at the start, we've seen the evolution of, Windows through the 90s to Windows NT to the current versions of Windows, and operating systems evolve. You've seen Linux come about. I remember it was 3 years ago this month that ChatGPT came out in December. I think it was like the first week. It's like, get an OpenAI account. You're seeing a whole nother kind of, area of technology developing very rapidly that is going to definitely make a difference in how things are done.
Totally. Hey, you mentioned the online community and the knowledge base. Those are certainly great resources for people who are looking to learn how to use a new instrument. Let's say the days of using a 300-page manual
Mm-hmm.
are gone in terms of training and onboarding. How has that developed over the years, and where are we now in terms of how Agilent brings new users up to speed?
Yeah, so we eliminated printed manuals more than 10 years ago. We got rid of printed manuals. So everything is provided electronically, and everything that we produce for the instrumentation can be served up from the instrument. You can access it with a browser interface. You can get to all that content. But today, to bring new users along, there's a lot of onboarding that you can do right at the instrument. It provides you a guided step-by-step introduction at the touch screen at first power on, and you can revisit that anytime you want. So if you get a new user in the lab and you say, hey, you need to go through the intro, they can go to the help area and say, okay, redo the onboarding on the touch screen. So that's in addition to computer-based introduction or electronic introduction that we have that's accessible to PC connected to the instrument, and it's served up, it lives on the instrument. So the training for the instrumentation comes from the instrumentation. And what you're finding now with this current demographic of you, they don't want a long training. They want like, hey, I need to do a task. Where's the 3-minute video I can watch? Or now you're searching it through Copilot or other AI tools. You just want it very quick. So we're doing a lot of looking at how to bring introduction. We've built it in, but even bring it forward further by making it more accessible, task purpose, shorter snippets of things. Because the way these users consume information, they don't want to sit in a 30-minute, or they don't want to sit in a webinar and be slide whipped for hours. They want to know, hey, I just need to know how to do this one thing. Where's the video that I can get how to do that? So we serve it up through a variety of multiple channels. I mentioned the community that's hosted on agilent.com. And then there are still people that want in-person training. When they buy an Agilent system, they get from our service team the installation. They also get an introduction at the time it's installed. And then there are offerings that they can get in-person training on site. They can do it at the customer site. Or here at Little Falls, we have Agilent University. The front lobby's always got a stream of customers signing into Agilent U. There's a really nice facility that they upgraded here, and people can send users for on-site training as well. So we're trying to satisfy a broad range of use cases and a broad range of users and needs. And I think we have pretty good offerings.
I think you nailed it as far as the age of the large manual is somewhat behind us in terms of now being able to ask specific questions on how to do one task. The idea of you needing to flip through a 300-page, whether it's physical or like a PDF document, just getting those
Yeah,
exact instructions. And I think for software in general,
yeah,
it's huge. Like we just switched to a new accounting software, and certainly happy to do a formal training if that made sense. But also, as you hit roadblocks, you now have tools that you can actually ask for step by step instructions on how to
yeah.
do something. It's game
It
changing.
definitely is. I can't remember the last time I've read a manual for any product I purchased. There's a tremendous amount of power and capability in the devices. And I realized like I learned something new every once in a while. That Notes app has become the new electronic file drawer because you can scan documents directly to that. You learn that from online, you learn that from forums. And if you want to go to the Genius Bar, you can go schedule a visit, go talk to a knowledgeable person. So, it's kind of similar in a sense like that.
If you're speaking to a lab director, what general advice do you have for them about their instrumentation strategy in general?
Okay, so I would think about kind of three things that I would be thinking about as a lab director. So one is around the goals. What are their goals for the laboratory? Are they inside a bigger enterprise and they're servicing that enterprise? Is their business about running samples? I think you mentioned cannabis earlier in the segment. And are they in that business to do contract stuff? And what do they need to improve? And if they're looking at their new instrumentation strategy, are they trying to improve efficiency, throughput? Obviously, we hear they're trying to reduce costs. Do they have sustainability goals in their enterprise they're trying to achieve? So I think the first area of questions around what are the goals for the lab? Second one, and we talked a lot about it here, is their users, the demographics of their users. How do their users work with instrumentation? How much staff are they going to have in their laboratory for the capacity that they're building? And where do they want their users spending their time? And then finally, in the users, how do their users consume information and provide the results of the lab? So I think they have to think about their goals. They need to think about the users, not just the users they have now, but if they're building a strategy, strategies are built for, not just this year and next, but they're built for 3 years, 5 years. They're building a longer term strategy. So they have to think about goals, users. And then the third thing, they need to consider what solution they want to deploy. So what set of capabilities do they have to have in a instrumentation strategy to help them achieve 1 and 2? Is it speed of analysis? Is it less energy usage? Uptime, the ease of routine maintenance? What's the reliability of those systems? And then which vendor can come and provide complete workflows? Because we talked a lot about instrumentation here, but sometime I'd love to come back and talk about what we've done for workflows, because it's not just the instrument, it's the sample and the sample prep into the lab. And then how does that get onto the instrumentation? What happens with the data? So who can come help this lab director with the complete workflow solution for their laboratory? And then finally, who could potentially have the scale and provide the support they need to make those systems most effective as a partner with that lab director? Not just a supplier or a vendor, but who's really invested in seeing them achieve their goals as a key partner with them. So goals, users, and solution are the 3 areas I would advise them.
That's a great answer. And I certainly connect that back to what I mentioned on automation earlier. Labs I visit, it seems like such a broad scale of a desired level of automation. And certainly that factors into all components, whether it's the people or the instrumentation. And certainly there's certain types of customers where they treat their time as free on the extreme side of it. Yes, it's a grad student there who's learning it, but that doesn't mean that they should be doing a overly time consuming process just because there's not a dollar amount assigned to their time.
Yep. It's people, after all, that are using these systems. I mean, we're human beings, and you're in charge of giving that result to somebody, your internal customer that needs it.
Jim, if you could wave a magic wand and instantly fix a recurring frustration for your users, what would that be and why?
That's a great question. I'd say in general, users of these systems get frustrated when they have to spend time on things that don't add value. So I would wave that magic wand probably around the area of data processing and review in the workflow. If I could just make, and again, this is blue sky, wave that wand and make it say, okay, it doesn't take you any time. That would please many people. There's so much potential to make strides in improving routine analysis tasks. The software systems, computational power is advancing. So I think I'd wave that wand there and make even greater strides ahead. That's a great question. There's other parts of the workflow we could improve, but I'll go with the data processing.
Fair enough. And I think you did a fantastic job commenting on this earlier, so hopefully this has been cleared up. But are there other misconceptions regarding what's called smart instrumentation or intelligent systems that you'd like to clear up for the
Well,
audience?
I'll give you one very concrete one, and I think this one I would definitely like to clear for everybody. And let me draw it to the experience most of us have. I don't know if you have smart things in your home. I've got plugs, I got a Ring doorbell, a Nest thermostat. So we're all consumed with this Internet of Things smart technology. And in your home environment, those things in general have some connection to the internet. The Ring doorbell doesn't get I can't see the thing on the Ring doorbell unless I'm connected to the cloud. Our smart instrumentation does not require to be connected to the internet. Okay. So we have all of this capability built into our smart instrumentation, but that can be set up in the lab environment. It can be set up with the computers and the systems within the network of the lab, and the user can derive all of the benefits we talked about, and it is not connected to the internet. So there is a difference between IoT and your instrumentation. Now, that being said, as I highlighted earlier, if your enterprise allows and you have the right IT security and the right VPN and the right setup, yes, I can dial into the VPN on my phone and I can get to the laboratory here because my enterprise allows that. So when we first introduced intelligent instruments around 2016, the first one, and we said, hey, there's a browser interface, people generally says, wait, it has to be in the internet? No, it does not have to be connected to the internet. It can be, but it doesn't have to be. So I think that's one misconception I'd like to clear the air about it is you can use all of this capability and it doesn't have to be internet connected. And if I could add one more misconception, or maybe highlighting, the capability of intelligence is distributed and built in the place where that data can be collected and processed. So we have stuff that's built into the instrumentation because there's a lot of knowledge built in there and you can make decisions, you can do analysis and stuff. But intelligence exists in the instrument. It's in the software. It's in the enterprise services that we offer. So we have an array of intelligence built in, and that allows a great deal of flexibility on how those features are realized and how the users derive benefit from that.
I think the internet connectivity item is especially important because somewhat of a knee jerk concern is, oh, it's in the cloud, our data's out there,
Right,
this is
right.
unsecure, and that's not really accurate.
That is not accurate. Correct. So, we've done our homework and we talk to our users. It's covered in the materials. And there's many people around the world who are experiencing the new intelligence systems that we have. For LC and GC, the Infinity 3 Lab Assist with the new capability with Infinity 3 is really remarkable leap forward for our LC portfolio. So, we've got intelligence being built in pretty much everywhere in the ecosystem.
And returning back to that feedback loop, you feel a whole lot better about putting in all that R&D time, knowing that people will adopt it if you can make sure that you're providing solutions for some of those concerns and making sure it's going to work within their frame.
I was at Gulf Coast Conference back in October and talked to many users, and it really is nice to hear when they are coming up and without asking, they're telling you how they're using the touchscreen on the 8890 and what they're able to do. And that's like, yeah, they're getting it. And that's really nice to hear because, we're doing this to make ultimately their job easier, but to make the world better that we're in, to drive better results and faster results. So it really is nice to hear that from the community.
Absolutely. I always like to ask as we're wrapping up, what did we miss today, Jim? Was there anything else that you wanted to get out there in the world?
I think we pretty much hit everything I kind of had in mind. I hope your listeners and your viewers found this interesting. Would love to in the future maybe get another opportunity to bring some new and updated information to your audience. I hope this gave them an idea of at Agilent, we really take solving their hard problems very seriously. We are there to partner with labs and our users around the world. We want to help them solve tough analytical challenges. And, closing, I get asked, people say 34 years, that's a long time. I really feel motivated by the impact that we have on improving the human condition in the world. You look at the food you eat safe because we're testing pesticide residue. I don't worry about my drinking water. Well, I did look at our water report for PFAS. So I know the water utilities have some work to do, but we have a safer environment, safer products, safer fuels, and forensics and drugs from pharma because of analytical instrumentation. And that is really motivating to me to be involved in this industry because it makes a really big impact on the human condition. So I think it's very exciting.
Yeah, it's a motivating space to be involved with for sure, feeling like we're contributing to some real world problems and some useful solutions. And as you mentioned earlier, I think we could have a whole nother conversation just on workflows alone and not
Yeah,
just
yeah,
instrumentation.
definitely.
Thanks so much, Jim. I really appreciate your time today and thanks for sharing all your insights with
Oh,
the
you're
audience.
welcome. Yeah, yeah, David, thank you for having me. And I look forward to talking again sometime in the future.